Hey, it's Miss Wesley, and it's time for some Algebra 2. We're looking at Statistics Packet page 22, rounding out the unit with section 1110 on normal distributions. You'll see the Philadelphia Eagles logo at the top, along with a list of the good and the bad memories of our winning percentages for the past 30 seasons. And I was thinking of a joke to tell you, and I would tell you a construction joke, but I'm still working on it. Check out the list. Each winning percentage is accompanied by the year that that season happened. And I want you to pause the video now and get these win percentages typed into L1. And then it says to sort the list. And we'll take a look at it together to see how we feel the data is distributed. So I would pause now, get those typed in. I took the liberty of typing my numbers into L1 on the calculator here. And my next step is to sort. So I'll quit out of it, stat, and then sort ascending, option 2. And I'll sort list 1, second and 1 for L1, enter. Now to just check, when I go back to stat and edit, I see a list that is in numerical order, and I can scroll up and down to see that these are the past 30 seasons of winning percentages. Okay, so does the data look, how does the distribution look? It says to look at, and what I would recommend is maybe we could look at a quick graph of this, because sometimes at first glance, the numbers are a lot to take in. I remember, what are our best seasons? Let's see the highest winning percentages. Yikes, we had 2 seasons. What were these years? So in 2004 and in 2017, both good seasons for the Eagles. We won over 80% of our games. Let's use a shortcut on this. We'll use the calculator to see a graph. So I'm going to hit second and y equals for stat plot. I'm going to turn plot 1 on. So I'll go into plot 1. If it's not already on, I'll turn it on. And I'll choose a box plot like we've already worked with that would show outliers. This option here, I'll hit enter. I'll just hit y equals to make sure that I only see one plot on and there's no equations in here. If so, I'll clear them out. And I'll graph it on a zoom 9 to see how I feel the data is distributed. Another thing that we haven't talked about a lot, but that I could look at, is a bar graph called a histogram that shows the frequency of how often each class of data is going to occur. So if I just sketch the box plot here, it looks pretty normally distributed. I could, and I'll tell you what that means too. I could draw a little box plot, no outliers present. And it seems like that middle 50% of the data falls roughly within the middle of the shape. There's also what we'll talk about later in the lesson. There's such a thing as skewed data. And good for the Eagles, it seems like a lot. So the max up here is 81.25%, and the min is down at 18.75. And you could look at the numbers and say that a lot of the seasons are up toward the high side. They call this skewed a little bit. It's slightly skewed, skewed left, or negatively skewed. It's kind of funny when the tail or the low end of data is toward the left side. They call that a skewed left data. But you could sort of kind of call this maybe a bell-shaped curve in a way that's a little bit off-center. If I was talking about that histogram, if I looked at a bar graph of this, the calculator has a way to make that quickly too, and it's easy once your numbers are in order. I could actually go to second. We haven't done this yet together, but I could go to second and y equals for stat plot, go back into plot 1, and let's pick the graph that looks like a bar graph, a frequency histogram. I'm going to hit enter for this third option. X list is L1, frequency 1, it's going to graph in blue, and I'll hit zoom 9 again. It's not a perfect picture, but you could trace around this graph and it'll show you, I should hit trace first, it'll show you the amount. There are 2 values that fall within this range from about 29 to 39. There are 7 values that fall in this range, right? And you have this high bar, go Eagles, up in the 60s, and then a couple that are in the 70s and the 80s for percentages. So if I were to sketch this bar graph, and this is a very, very rough sketch, I got a couple low bars down here, and then a high bar was looking something like this, where you get that same sort of shape. So I'm going to guess a little bit skewed to the left and sort of like a bell. And bell-shaped is what we want to talk about today in this lesson. Second, use the calculator. It says find the mean and standard deviation of the data. So for that, I can go to one variable statistics. So I'll quit. And it's stat calc. We've been using this a lot. One variable statistics, great review for L1. And I'll record things like the mean and the standard deviation. And I'm going to use population standard deviation, that 15.398. So the mean when rounded is about 56%. 56, we'll say maybe to two decimal places, 0.46. And the standard deviation, population standard deviation, is about 15.398. So let me just round it to 40 like that. And we get this series of questions below that will preface the lesson for today about the number of seasons that are within certain ranges. And we've talked about this a tiny bit with standard deviation. It's great review. But how many seasons were we within one standard deviation of the mean, whether it was above or below? Well, let's get ourselves some endpoints. I want to take the mean plus one standard deviation, as well as the mean minus one standard deviation, and get an approximation. Feel free to pause as you type the values in. I'm just going to do the addition and subtraction. I get 71.86, and I know that's rounded for a high cutoff, and 41.06 about for a low cutoff. Well, if I look at my sorted list, it'll be easy to knock out a couple seasons that don't fall in that range since I have everything in order here. So the low cutoff was only a 41, and there are 1, 2, 3, 4, 5 values below the low cutoff. Let me go to the high end. So 5 values below. The high cutoff was a 71.8. So do we have any seasons above that? We had a couple, right? 1, 2, 3, 4 seasons that were above that. That gives us 5 plus 4, or 9 seasons that are they're outside of one standard deviation from the mean. And there are 30 total seasons. So 30 minus that 9 gives you 21 seasons as an answer to this question in number 3. And the follow-up you're going to usually see is, what percent of the data does that represent? Well, that's 21 seasons out of the 30 total. And we'll just round that to the nearest percent. Well, 21 out of 30 gives you exactly 70%. So remember this, 70% of the data falls within one standard deviation of the mean. Let's try the same thing for 2 and 3 standard deviations above and below the mean. So here in number 4, I want to add 2 standard deviations, and I want to also subtract 2 standard deviations from the mean. Let's give that a try. So the calculation should give me 87.25. I'll just go nearest 10th, 87.3. I'll say 2.5. I guess the data is to the nearest 100, so I might as well. And then what's the other one? 25.66 would be your low cutoff when subtracting. So let's go back to the list. Do we have any values outside of this range? So anything below 25.66. What were our worst seasons here? Let's see. We had an 18.75, and this 25 here also counts as being below that low cutoff. The high cutoff was 87.254, and our best seasons were only 81.25, so actually nothing's above the high cutoff. I'm only calculating 2 of all the 30 seasons. It's so rare to be outside of 2 standard deviations of the mean. And that means our answer isn't 2, right? 2 are outside of that. 28 seasons are within that range. And that percentage is almost the entire set of data. 28 over 30 gives you 93.33%, 93.3% of that data. Okay, interesting. We've almost hit all the data. Once we go 3 standard deviations above and below, I wonder if we've covered everything. So if I take the mean, and I add 3 standard deviations, let's see what I get. Plus 3 standard deviations. I use the calculator, add them together, and I'm above 100%, 102.65. So no seasons better than 3 standard deviations above. Any rare seasons that were lower than 3 standard deviations below? Luckily for the Eagles, no. No season was below a 10.24 winning percentage. So all 30 seasons fall in this category. The follow-up percentage is 100% of the seasons. And what I was getting at here, what you notice with a lot of real-life data, it tends to fall in what's called a bell curve or a normal distribution. And I want to talk about this data. Actually, this is real life data, and these percentages line up with the rules we're about to go over for normal data. Many common statistics, people's height, weight, blood pressure, gathered from samples in the real world have a normal distribution about their mean. And I'm sure that you've heard of a bell-shaped curve before, and we're going to do our best to be able to construct these bell-shaped curves today and talk about how data is distributed normally and what that means for your percentages of data around the mean. Some people call this, okay, so underline the keywords here. If you see bell-shaped, if you see the term normal curve, Or if you see empirical rule, which is also sometimes called the 68, 95, 99.7 rule. These percentages do appear on the chart you see below. The mean of the data is right in the middle of the bell curve, right? One above and below is the middle. 68% of the data falls within one standard deviation. And this is just an approximation. That's a quick number we can use. When we answered this for real life data, we didn't get exactly 68%. We got 70%, but close enough, right? Approximation. If you want to go further out from the mean, 2 standard deviations is going to encompass almost everything. 95% of the data in general with normally distributed data falls within 2 standard deviations of the mean. So almost everything. By the time we got to the question about 3 standard deviations above and below, you pretty much said it was all the data. So from 3 above to 3 below, 99.7 statistically percent of the data is going to fall within that range, 99.7. And you see these percentages listed to the side. So these are the numbers we're going to keep in mind as we try some practice problems over the next couple lessons. And do you notice that in this picture here, those percentages are divided in half in a way? So if 68% falls in the middle and this whole shaded range, well, that means half of it's above the mean, half of it's below, 34%, 34%. You could say this whole thing is 95%, and if you subtract 68 and take half of that each time, you get 13.5% in this little chunk, in that little range there for 2 above and below. You have a 2.35% for these two tails out here, 2.35 and 2.35. You can get that by taking 99.7 minus 95 and splitting that in half to get those green values. And there's 2 percentages that aren't listed on the picture, the end tails. If you take 100% minus 99.7% and split that in half, you get a tiny, tiny bit. You get 0.15% for this tiny tail on the outside of 3 standard deviations below, and 0.15% for that tail that is above, okay? So in a second, we're going to get to some practice problems. I want to talk about skew with you too. Sometimes data in real life, we have to acknowledge that our real numbers aren't always going to be exactly like a bell curve, normally distributed like this middle picture with the mean right in the center. A data set could have a distribution that is skewed one way or the other. We mentioned this briefly on the last page. It's asymmetric. You have positive skewed, where a lot of the values, if this were a bell curve, many of the values fall on the low side. They also call this skewed right. It's kind of ironic because most of the data values are on the left side, but the tail is to the right. It's like you're pulling the data and the tail goes to the right, versus negatively skewed data, which is what I hope would happen on a quiz or a test in this class. Lots of grades up in the 80s and 90s and very few grades out to the left side tail. And they call this left skewed or skewed to the left. Like that. Now you'll see a table underneath where we have to make some approximations here. We're going to try to, I think I want to take each one of these bars. Feel free to pause the video, briefly go through, and right at the top of the bar, an estimate for what you think the percentage of bears is going to be. So I think from 80 to 90, it's about 1% of bears. Here you've got 5 there. In between 20 and 30 on this one, I said about 23% I was estimating. Up here I said 42 when I was trying to read the table, a 23, and then I think I didn't need these. It was like a 5 and a 1 again. So the data is real life, but it's approximately normally distributed. What percent of brown bears weigh between 100 and 129? Well, now that I have these totals, I can just add those 3 values. 23 plus 42 plus 23. It's going to give me an approximation of 88%. Number 7, approximately what percent weigh less than 120? I can add up all these. 1 plus 5 plus 23, I think, plus 42 gets me all the way to a percentage of 71, like that. And the third question, the standard deviation in weights of bears is about 10 kilograms. Approximately what percent have weights that are within 1.5 standard deviations of the mean? You can check on this one, try this one on your own, take the mean. You're going to add and subtract 1.5 times 10, and then just take a look at the data and see if you can answer the question from there. Your range is 125 for a high cutoff and 100 for a low cutoff. And it looks like that goes from 100, I'm going to say almost up to 129. So roughly 23 plus 42 plus 23 gives me 88%. Okay? Tune back in and we'll flesh this out, explain it a little bit better, and I'll see you next time.